This is SpaceTime Series 22, Episode 71. Coming up on SpaceTime, what the geologic record tells us about the day the dinosaurs died, the asteroid-triggered ice age that changed life on Earth forever, and scientists invent the blackest black yet. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has provided scientists with the most detailed look yet at the events which ended the age of dinosaurs, creating one of Earth's worst ever mass extinction events. The KT or Cretaceous Tertiary Boundary event, which these days is often referred to as the KPG or Cretaceous Paleogene extinction event, occurred some 66 million years ago when an asteroid 10 to 15 kilometers wide slammed into a shallow sea off the coast of what is now the Gulf of Mexico's Yucatan Peninsula. This massive impact released as much energy as 100 teratons of TNT. That's more than 10 billion thermonuclear bombs. The collision was so devastating it wiped out 75% of all life on the planet, including all the non-avian dinosaurs. The initial impact created the 180-kilometre-wide Chicxulub crater, throwing molten ejecta and debris high into the atmosphere and triggering a massive tsunami hundreds of metres tall, together with the most devastating earthquakes known as land tsunamis and volcanic eruptions which shook the entire planet. The shockwaves from the collision were powerful enough to circle the entire Earth, and burning debris from the impact ejecta began raining back down onto the surface, causing an intense pulse of infrared radiation, which began literally cooking any exposed life, and combining with molten lava flowing from the volcanic eruptions to spark global wildfires, which burnt out vast swathes of vegetation, killing almost all life on the planet that somehow managed to survive the initial blast wave. The asteroid impacted the planet at a location rich in sulfate-containing gypsum, which was instantly vaporized and dispersed as an aerosol into the atmosphere, only to fall back down as highly caustic acid rain, burning anything it touched. Smoke and ash from the wildfires and volcanic eruptions, together with dust from the ejected debris, blocked out sunlight for months if not years on end, halting photosynthesis in plants and creating an impact winter that caused temperatures to plummet, producing long-term effects on the climate and food chain. Evidence for the global nature of this event can be seen around the planet in the form of a dark clay boundary line in the geological record. Known as the KT event boundary, it contains high levels of the metal iridium, which is rare in Earth's crust but abundant in asteroids. The new study, reported in the Proceedings of the National Academy of Sciences, looks at detailed rock core samples through hundreds of meters of debris that filled the actual impact crater at ground zero during the first 24 hours after the asteroid hit. An international team of more than 24 scientists contributed to the study, which was carried out as part of the 2016 International Ocean Discovery Program scientific drilling mission, led by Professor Sean Gulick from the University of Texas. The authors found the core samples they were studying included bits of charcoal and jumbles of rock brought in by the tsunami's backflow, but there was a conspicuous absence of sulfur. The new work builds on earlier studies describing how the crater formed and how life recovered at the impact site. The authors found that most of the material that filled the crater within the hours after the impact was either produced at the impact site or was swept in by seawater pouring back into the crater from the surrounding Gulf of Mexico. It turns out just a single day saw the deposit of 130 meters of material. That's a rate among the highest ever encountered in the geologic record. This extremely fast rate of accumulation means the rocks were recording what was happening in the environment within and around the crater within minutes and hours after the impact, and provides clues about some of the longer-lasting effects of the event. The blast triggered a massive tsunami that reached as far inland as Illinois. Inside the crater, researchers found charcoal and a chemical biomarker associated with soil fungi within or just above layers of sand that show signs of being deposited by resurging waters. Now, this suggests that the charred surrounding landscape was being pulled into the crater with the receding waters from the tsunami. Finding evidence of wildfires helps scientists know that their understanding of the asteroid's impact is on the right track. However, one of the most important takeaways from this research is what was missing from the core samples. The area surrounding the impact crater is full of sulfur-rich rocks, but there was absolutely no sulfur in the core. That finding supports the hypothesis that the asteroid vaporized the sulfur-bearing minerals present at the impact site, and it released that into the atmosphere, where it wreaked havoc with Earth's climate, reflecting sunlight away from the planet and causing global cooling. Researchers estimate at least 325 billion metric tons would have been released by the impact. Now, to put that in perspective, it's about 4 orders of magnitude greater than the sulfur that was spewed into the atmosphere during the 1883 eruption of Krakatoa, which cooled Earth's climate by several degrees for over 5 years. One of the study's authors, Professor Cleety Grice from John Curtin University, says the findings help answer that tantalising question of exactly what happened in the immediate aftermath of what, after all, was one of the most significant events in Earth's history.
We were involved in looking at the molecules in the rocks, actually extracting the molecules out of the core, which was retrieved in 2016. And the sorts of compounds we extracted are called polycyclic aromatic hydrocarbons. One particular one is called perylene, which is a marker of a pigment made by fungi which degrade wood in situ. And therefore, when we found this marker in the rocks, it was very high at the height of the tsunami layer, which was identified by the geologists. And the fact that it is very high relative to some of the combustion markers indicated that it had been transported rapidly into the crater after the impact. And the timing of this was probably within a day. So we had a wave of about several hundred meters high, which flushed material back into the crater after the impact.
A 10-kilometre wide asteroid slamming into the ocean at that point, and as it did so, all the water was flung out, caused massive tsunamis, and a lot of that water wound up on land. It then backwashed back into the crater, backfilled, grabbed all the land with it that was nearby, and that's how you have found these markers.
Yeah, I would say that the one important thing is that this meteorite actually hit a shallow carbonate reef platform, so it wasn't deep ocean, it was a big reef platform, and the meteorite created a crater of about 180 kilometres wide. The impact from the asteroid was probably equivalent of several million nuclear weapons detonating simultaneously, so it was quite a catastrophic event, and there was lack of light for many organisms due to the atmosphere being affected and the lack of sunlight due to all these aerosols and vaporization of material, and therefore there's a collapsing phytoplankton productivity in the oceans as well.
When I did research into this, the thing that amazed me was that had the KT boundary event asteroid hit just about anywhere else on the planet, the non-avian dinosaurs may well have survived. It was because it landed where it did. It hit a sulfur-rich area, and that sulfur was then thrown everywhere. It went all through the atmosphere.
Yeah, the toxicity in the atmosphere and the lack of sunlight, which has a global cooling event.
Yeah.
So going from extreme warm to extreme cold conditions.
The impact winter.
Yeah. So it was quite dramatic, very quick in terms of when things start to happen. It's almost immediately. The big asteroid caused havoc. I guess what's interesting in what Sean Gulick did in his work is, who's the first author, is to find actually not the absence of sulfur in the crater, and that was probably due to a rapid volatilization of sulfur-rich minerals when the impact occurred at the Chicxulub site.
It wasn't a good day to be around, was it?
No.
That's Professor Cleety Grice from John Curtin University. And this is SpaceTime. I'm Stuart Gary. Now let's stick with the asteroid disaster theme. And scientists have found that a cataclysmic collision in the main asteroid belt 466 million years ago triggered a major ice age on Earth which changed the evolution of life on the planet forever. The findings, reported in the journal Science Advances, claims the collision and subsequent breakup of the asteroid debris between Mars and Jupiter filled the entire inner solar system with so much dust it caused a unique climate change event triggering higher levels of biodiversity. Over the past few decades, researchers have begun to understand that evolution of life on Earth depends to a huge amount on astronomical events in space. One example is the KT boundary event 66 million years ago, which wiped out all the non-avian dinosaurs. And now scientists can present another example of how extraterrestrial events have changed the evolution of life on Earth. Researchers found that the destruction of a 150-kilometre wide asteroid partly stopped sunlight from reaching the Earth, in the process triggering an ice age. Now, the authors claim that the climate changed from being one more or less homogeneous right across the planet to becoming one divided by different climatic zones, with Arctic conditions near the poles and tropical conditions at the equator. And a higher level of diversity among invertebrates came as a direct adaptation to the new climate triggered by the exploded asteroid. The study's lead author, Professor Birger Schmitz from Lund University, says it's analogous to standing in the middle of a room and smashing a vacuum cleaner bag, only on a much larger scale. The authors reached their conclusions by measuring extraterrestrial helium in petrified seafloor sediments found in southern Sweden. See, on its way to Earth, the asteroid debris dust would have been enriched with helium from the solar wind. Normally, helium atoms have 2 protons, 2 neutrons, and 2 electrons. But helium shot out from the sun and the solar wind can be missing a neutron. The presence of these special helium isotopes, along with rare metals often found in asteroids, proves that the petrified seafloor sediments originated from space. Normally, the Earth gains maybe 40,000 tons of extraterrestrial material every year. But the petrified seafloor sediments show that this increased dramatically over a period of at least 2 million years, around 466 million years ago. And that date's important, because other studies had already established that the Earth was undergoing an ice age at around the same time. The amount of water in Earth's oceans influences the way rocks on the seabed form, and the rocks from this time period show signs of shallower oceans, a hint that some of Earth's water must have been trapped in glaciers and sea ice. The timing of the ice age synced up nicely with the extra dust in the atmosphere. Schmidt says the findings were completely unexpected, but they show for the first time that at times these interplanetary clouds of dust blocked out sunlight and dramatically cooled the Earth. The good news is that since the dust floated down to Earth over at least 2 million years, the cooling was gradual enough for life to adapt and even benefit from the changes. An explosion of new species evolved as life adapted to survive in regions with different temperatures. I'm Stuart Gary. This is SpaceTime. From time to time, we get inquiries from our listeners asking how they can support our show. And that's why we've set up a Patreon account. For just a few dollars a month, you'll get access to a slick commercial-free double-episode version of the show each week, as well as bonus audio content not included in the regular show, plus other rewards like an invitation to join our special patron-only Facebook group. You can get all the details at Patreon, spelled Patreon, patreon.com/spacetime with Stuart Gary, where you can see the various reward levels available and what works for you. And of course, you'll have the satisfaction of knowing that you're helping us develop our show into the future. That URL again, patreon.com/spacetime with Stuart Gary. And you can find all the details in the show notes, or just click the orange button on our website. And thanks to all our patrons, because it's your generosity and support that helps keep our show going. Astronomers have discovered the most massive neutron star ever detected. The findings, reported in the journal Nature Astronomy, suggest this newly discovered object is almost too massive to exist. Neutron stars are created when very big stars far larger than our Sun reach the end of their lives and explode in powerful events known as core collapse supernovae. What's left behind one of these blasts is a highly compacted, super-dense stellar corpse, in which the positively charged protons and the negatively charged electrons are literally crushed together to form neutrons, hence the star's name. In fact, other than black holes, neutron stars are the densest known objects in the universe. Just a sugar cube-sized piece of neutron star material would weigh 100 million tons. Neutron stars are thought to be composed of a solid, rigid outer crust or shell composed of ions and electrons. Directly below this is a fluid inner crust up to 2 kilometers thick, made up of electrons, neutrons, and atomic nuclei. And this surrounds a 9-kilometer thick outer core of neutron-proton Fermi fluids and electron Fermi gas. A neutron star's inner core, which will be about 3 kilometers in radius, is probably composed of quark-gluon plasma, the first matter to form in the universe after the Big Bang 13.8 billion years ago. Neutron stars rotate very rapidly, generating powerful beams which are thought to emanate from near their surface. And if the rotational axis of the neutron star doesn't line up with its magnetic poles, then the star emits a sweeping beam of energy, flashing across the cosmos like a lighthouse beacon. We call these pulsars. Though astronomers and physicists have marvelled and studied these objects for decades, many mysteries about neutron stars still remain. Do crushed neutrons become superfluid and flow freely? Do they break down into a soup of subatomic quarks or other exotic particles? And exactly what's the tipping point when gravity wins out over matter and forms a black hole out of a neutron star? Well, now astronomers using the giant 100-metre Greenbank radio telescope in West Virginia have come a step closer to finding some of these answers. They've discovered a rapidly rotating millisecond pulsar called J0740 plus 6620, located some 4,500 light-years away in a binary system with a white dwarf, the stellar corpse of a formerly sun-like star. The authors found that the pulsar was the most massive neutron star ever measured, packing some 2.17 times the mass of our Sun into a sphere just 30 kilometres across. The measurement approaches the limits of just how massive and compact a single object can be without crushing itself down into a black hole. See, recent work involving gravitational waves observed from colliding neutron stars by LIGO, the Laser Interferometer Gravitational Wave Observatory, suggests that 2.17 solar masses might be very near the 2.3 solar mass limit they've calculated. Finding the maximum mass that physics and nature allow will teach astronomers a great deal about this otherwise inaccessible realm of astrophysics. So how'd they do it? Well, pulsars spin at a phenomenal speed and regularity, allowing astronomers to use them as sort of cosmic equivalents to atomic clocks. Such precise timekeeping helps astronomers study the very nature of space-time, measure the masses of stellar objects, and improve their understanding of general relativity. In the case of this binary system, which is seen nearly edge-on in relation to the Earth, this cosmic precision provided a pathway for astronomers to calculate the mass of the two stars. As the ticking pulsar passes behind its white dwarf companion, there's a very subtle delay in the arrival time of the signals. It's only on the order of 10 millionths of a second, but it's measurable. Now, this phenomenon is known as Shapiro delay. In essence, the gravity of the white dwarf is slightly warping the space-time around it. That's in accordance with Albert Einstein's theory of general relativity. And this warping means the pulses from the rotating neutron star have to travel just that itsy-bitsy further as they wind their way around the distortions in space-time caused by the white dwarf. And once the mass of one of the co-orbiting bodies is known, it's a relatively straightforward two-body problem to accurately determine the mass of the other, in the process ever so slightly cracking open a new window into an extreme form of physics. I'm Stuart Gary. This is SpaceTime. A meteor has flashed across the evening skies of Victoria, Tasmania and southern New South Wales. The bright fireball lit up the skies with an orange glow and blue-white tail at around 8:30 on Friday evening. It was followed a few moments later by a loud thunderous rumble before fading from view at an altitude of around 20 to 30 kilometres. Although the event looked spectacular, it was most likely caused by a meteor no larger than a soccer ball. Do you remember Vanta Black, the blackest black ever made? So dark that it would absorb 99.96% of all visible light that hit it. The name was a compound of the acronym Vanta for vertically aligned carbon nanotube arrays, and black, well, because it was so dark. Vanta Black's secret was a forest of vertical tubes, grown on a substrate using a modified chemical vapor deposition process. When light struck Vanta Black, instead of bouncing off, the photons became trapped and were continually deflected among the tubes, eventually becoming absorbed and dissipating into heat. Well, now MIT scientists have gone a step further. They've come up with a new material, well actually a refined version of the same, which can absorb 99.995% of incoming light. That's 10 times blacker than Vanta Black. The new material, which is yet to be named, is also made out of vertically aligned carbon nanotubes grown on a surface of chlorine-etched aluminum foil. As well as reporting their research in the journal ACS Applied Materials and Interfaces, the authors are also showcasing it as part of the Redemption of Vanity art exhibition at the New York Stock Exchange. The display features a sparkling 16.78-carat natural yellow diamond, estimated to be worth over $2 million, but coated with the new ultra-black carbon nanotube material. The resultant effect is absolutely stunning, with the normal, brilliantly faceted gem appearing as a flat black void. Aside from making an artistic statement, this new material could also be of immense practical use for things like optical blinders to reduce unwanted glare on space telescopes searching for exoplanets. China has launched a new Earth observation satellite. The ZY-102D was launched aboard a Long March 4B rocket from the Taiyuan Satellite Launch Center in northern China. The probe will aid Chinese mining companies by providing data on minerals and natural resources for the next 5 years. As well as the primary payload, 2 smaller satellites were also piggybacked onto the mission. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found that air pollution can enter the placenta. A report in the journal Nature Communications has found black carbon particles on the fetal side of the placenta in women exposed to air pollution during pregnancy. These particles are released largely from the combustion of fossil fuels and are thought to impact pregnancies through preterm births and low birth weights. Using high-resolution images, researchers studied 28 women finding black carbon in all 28 placentas, with women exposed to the highest levels of air pollution during pregnancy having the highest levels. A new study warns that Victoria's conservation reserves are failing to protect threatened species such as the leadbeater possum and the greater glider, with the best areas for survival being deliberately allocated to logging. The research, reported in the journal Austral Ecology, found Victoria's current reserve system is simply inadequate for the protection of threatened species. Scientists from the Australian National University identified areas that are important to 70 threatened forest-dependent species. They found that areas with the highest value for wildlife were often found in logging zones rather than conservation reserves. Scientists warned this is part of a growing tendency to put conservation reserves on land which is the least valuable to industry. Researchers say conservation reserve areas need to be determined based on areas most critical to the survival of species, and not simply those areas that are least valuable to industries such as forestry. Well, some Microsoft customers were kept waiting for several hours last week when software issues prevented Skype from working correctly through Microsoft operating systems. The glitch prevented Skype from recognizing user passwords, resulting in notifications wrongly claiming incorrect passwords, and too many password login attempts were undertaken despite the correct passwords being supplied on the first attempt. To make matters worse, customers trying to resolve the problem were kept waiting for Microsoft customer support for over 3 hours before the line finally dropped out. The failure was eventually traced to security rules affecting the compatibility between Microsoft passwords and Skype IDs. Despite requests, there's been no word from Microsoft on the reasons for the sudden compatibility issues. Scientists have developed a cheap thermoelectric device that harnesses the cold of space to generate electricity. A report in the journal Joule claims researchers have now used the device to power an LED. The researchers developed the device by taking advantage of radiative cooling, where a sky-facing surface radiates its heat into the atmosphere, losing some heat to space and reaching a cooler temperature than the surrounding air. While the energy it produces is relatively small, researchers say it could be used to generate power in remote locations, especially at night, and eventually be improved over time for more widespread use. Does your dog look to you for help? Well, Italian scientists have shown that different dog breeds look towards their masters for help to different degrees, and that may reflect how close those breeds are to their wolf ancestors. Researchers trained 3 breeds of dog to find food hidden under an upturned metal strainer. They then made the task impossible and unbearable if you're a dog by screwing the strainer down over the food. A report in the Journal of the Royal Society found that Labrador retrievers looked to humans for help more than Czechoslovakian wolfhounds did. And the researchers found that German Shepherds fell in the middle between the two. Scientists say the differences are likely down to the more wolf-like genetics of some breeds over others. Well, one of the world's leading consumer electronics and home appliances trade shows, the IFA, has been held in Berlin. Big screen TVs are among the highlights this year, with LG offering their new signature 8K OLED Z9, which will set you back a cool $61,000 in the land of Oz. Meanwhile, Jabra revealed their new Elite 75T wireless earbuds, which offer 50% greater battery life. But for many, the star of the show was Samsung's remake of their infamous Galaxy Fold. Only time will tell if the redo lasts any better than the original, which turned out to suffer from significant screen damage. With all the details, here's Alex Horosh from whistleout.com.au.
Foldable smartphones are back. Earlier in the year, Samsung was almost ready to launch the Galaxy Fold, its first foldable smartphone, but then it kind of started falling apart in reviewers' hands with screen malfunctions and other technical issues, which isn't great. So that launch got shelved, and Samsung spent a couple of months fixing up these problems and addressing these issues, and now it's ready to start selling the Galaxy Fold again, and it already has gone on sale in South Korea. It's coming to other markets this month, and Australia shouldn't be too far away. The Galaxy Fold is essentially a smartphone that can double be both a phone and a tablet. When it's closed, it looks kind of like a candy bar phone from maybe like the mid-2000s with a smallish screen that you can then open up, and you'll have a device with a 7.3-inch display inside. So it does kind of go between smartphone and tablet, and it actually does so like fairly seamlessly. If you've got an app running on the front, for example, like even like a text messaging app or Netflix, YouTube, opening up a phone will then seamlessly move that up onto the inside screen. So it's kind of like having two devices in one.
They promised us the phone wouldn't break when it folds, and it clearly has in the past. It's got to be something people are concerned about.
I'm sure it is, and I don't know who should buy this. It's $3,000 and it's a first-generation product. These early adopters will allow Samsung to keep investing into foldable technology, and it will keep getting better. It will keep getting more refined, and maybe in like 3 or 4 years, these will become polished enough that they become almost the mainstream. I think it was like similar with early smartphones. And Samsung isn't the only one working on foldables. Huawei's also got its Mate X, which is a bit of a different approach to a folding phone. While Samsung's kind of opens up like a book with two different displays, the Mate X just has one display that opens up. I think the Mate X is the sleeker of the phones, but it works better when it's not folded because you still have a 6-inch screen that you can use. So it feels like a regular phone that can just become a bigger phone. But it's also more expensive. We're expecting a local price tag of around $4,000, which is pretty eye-watering. So again, it's almost like one of these status symbol phones where it's like, yeah, no, I'm one of the first people to have this weird new technology. I've been like writing about phones for 5 years. That's a long time. So personally, I'm just really excited to just see something fresh happening in the industry that actually has a sense of promise. It feels like this is more than a gimmick.
That's Alex Horush from whistleout.com.au. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favorite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.